we're talking about today are hyperbolas. Hyperbolas is the standard form of the equation with the center. HK is that, right there on the board, front and center, on your formula sheet. Do you all see it? Now, the magnificent thing about this is here's your x and y axis. If it's on the horizontal, it looks like this. And what you're going to see are asymptotes. Okay? Asymptotes create that lovely look. You get parabolas on their sides, opening on the x-axis. Does that make sense? If I have opening on the vertical axis, it's going to look like this. And again, we have our lovely little asymptotes there as well. Notice how the formula changes. The center stays the same. The center is still HK, whether I'm a transverse axis horizontal or vertical. Okay? What changes, though, the x minus h squared, whenever it's horizontal, it's first, but whenever it's vertical, it goes second. Do we understand that? A and B remain the same. I repeat, A and B remain the same. Y'all okay? If you look at your equations from yesterday with the ellipses, what is the difference between the ellipse equation and the hyperbola equation? The ellipse is plus, okay? And what I want you to do is I want you to physically think about, here's your ellipse, you with me? And what it does is whenever it does the minus, it reflects the stuff in this direction. Do we see that? It takes the green and it pulls it on the outside and reflects it. Does that make sense? That's what the minus does. So basically the hyperbola and the ellipses are very, very, very similar equations, okay? And that's where you're going to get those asymptotes coming from. Do we see that, yes or no? Okay, yay, nays? Okay, now, for the project that we're going to be talking about here in the next couple of days here in the following week, what I just need you to know is I need you to understand that this is a conic. All the things that I gave you, circle, ellipse, and hyperbola, are all conics. That's what those are. All right? Now, with that said, I just need you to be able to identify the formulas, and I need you to be able to say, okay, well, what is my center given this equation? Write that down now. Write that down. Write this down. Take a little note. If you could speed it up, I'd really be thankful. I do. I'm still me. Aw, I'm always nice. Okay, biggest thing you need to understand is, first of all, is it plus or minus how those two fractions are connected? Minus and it equals the value 1, which means it's hyperbola. If it was a plus sign in between there and it equaled 1, you would say what? Ellipse. Do we all understand that? Yay or nay? Good. Okay, so with that said, I see that the x is first, so I need to find a few things. Okay, those are the things that I need to find. I need to find the center, I need to find the A value, the B value, and the transverse axis, meaning is it going to be an ellipse that's turned inside out on the horizontal x-axis or on the vertical axis y? Does everybody understand that? Okay, so with that said, my center is what? It is HK, which is going to be 1, 3. Y'all good? My A and my B values never, ever, ever change. Do we get that? A is always underneath the first fraction. B is always underneath the second fraction. Okay? So my A value is going to be the square root of 9, which is going to be 3. My B value is the square root of 16, which is going to be 4. Y'all good? Okay, and the last thing is the transverse axis. Here's what you need to know. What do you see in this position? The x. So therefore, this is going to be a horizontal. Y'all good? Very easy. All we're doing is the basics. I'm not trying to do any of the foci or any of that today. If you would be going through this and I'd be asking you all the information you need to know, we'd be looking for the focus on each side, which would be called the foci. We're not going to do that right now. We'd be also looking for the asymptotes. We're not going to do that right now because I want you to be able to utilize this, and that's going to be talking about using it in the picture project, which is just shifting it up, down, left, right, stretch, compress. You with me? So moving right along, same exact concept. I need 4 things. What are the 4 things I need? I need my center, I need my A value, my B value, and I need my transverse axis. Okay, now I want to draw your attention to what we have going on here. What is first? The y equals, right? The y minus the k is first. If you look at these formulas, the y minus k is what moves. That's what makes it change. The x in the changes. H is always with x, k is always with y. So if we're looking here, my center is, this is my k value, this is my h value, so what is going to be my center? Very good. And my a value is? I said the a and the b values do not change positions, didn't I? So that means my a value is the square root of 9, which is 3. My b value is the square root of 4, which is 2. And since my y values are first, I have a vertical one. So what does this mean? It means that I took my vertical ellipse and I am going to simply turn it inside out. Do we see that? Yay, nays? That's what that means. Does everybody get that? Yes or no? Okay, perfect. Now, moving right along, that's the front side of your worksheet, okay? I need you to be able to develop the equations so that you know what to put them in your calculator as. Does that make sense? So it says find the equation of the hyperbola with the below information and solve it for y. Exactly like you did with your circle and your ellipse worksheets yesterday. Exactly the same. So I give you h, I give you k, and you have a and b. So I am having what type of an axis here? Horizontal. So in my equation, which one goes first? X. So my equation is going to be x minus h squared over a squared minus, because that indicates hyperbola, y minus k squared all over b squared, and it always equals the value 1. Everybody good? And I plug in what I know. So this is going to be x minus 1 squared all over 2 squared minus y minus negative 7 squared all over 4 squared is equal to 1. Aw, that I did. I was just checking to make sure y'all were awake. We're going with that. That's my story. I'm sticking with it. It has a great ending. So I'm going to go ahead and I'm going to make these and calculate this. So this becomes x plus 7 squared all over a 4 minus a y minus a 1 squared over a 16 is equal to 1. Now, what I need you to do is I need you to be able to learn how to graph these. So how do I graph something? You got to solve it for y, because you can't put anything into a graphing calculator until you solve it for y. Okay? So if we solve this thing for y, I need to take the entire fraction that is right here. I need to take this whole thing over to the other side, so that's going to give me what? Okay, where do I put this negative? Does it matter if I put it to the top or the bottom? So where would the logical place be to put this thing at? I would put it in the bottom with the 16. It makes everything a whole lot easier. So if I put that negative with the 16 in the bottom, how do I get rid of that negative 16 now? I'm going to multiply both sides by negative 16. So I have y minus 1 squared is equal to negative 16 times 1, parenthesis, x plus 7 squared all over 4. Now what? Square root. And when you do a square root, what happens? Absolutely. Then what? Talk to me. You're getting road rash. What's up? We multiply both sides by -16. Did you do that? Okay. How do I get rid of this power of 2? Okay, don't distribute. It makes it ugly. Okay, so now what? Add 1. So y is equal to 1 plus or minus the square root of -16 parentheses 1 minus x plus 7 squared all over 4, close. Now, you have 2 parts of this. You have the positive portion and you have the negative portion. Do we all understand that? So you would actually have to do 2 things. You'd have to put f1 equals 1 plus that junk, and then f2 would equal 1 minus that junk. You with me? So you'd have to put this into 2 functions, or you could make a piecewise function. And a piecewise function is whenever you do the bracket, you with me? And you would have the first part right here, and then the second part right here. Does everybody see that, yes or no? Okay? Now, I'm going to show you how to graph these so that you can physically see what the hyperbola looks like. So I want you to all go ahead and get a new graph up. Please do not use, I repeat, please do not use the sketch pad whenever you are doing things like this, okay? Go ahead and get a new document and use a graphs page. So if I do a graphs page here, and if I want to go ahead and put this in 2 separate functions, I'm going to just go ahead and start typing it. 1 plus the square root of -16 parenthesis. Anybody remember what that was now? 1 minus x plus 7 squared over 4. And that was it, correct? So if I hit enter, what you're going to get is you're going to get the positive portion of this, the plus part of it. So I'm going to hit tab, and I'm going to arrow up once. If you triple click, you can hit Control-C to copy that. Triple click right here. If you triple click and hit Control-C and then arrow down and then hit Control-V, you have to backspace, though, and get rid of that F1 equals stuff. And you're going to replace the plus sign beside the square root with a minus. It saves you a lot of typing, doesn't it? Hit tab to be able to get to F2. And whenever I hit enter, it now gives me the second part of it. Do we all understand that, yes or no? We'll walk through this again tomorrow. Don't worry about it if you don't understand. I'm just showing you how to do it now. Okay? So I see how I have it in 2 different functions there. Do we all see that? Now what if I wanted to put it in 1 function? So I'm going to hit Control-Z, and I'm going to, this time I'm going to delete all this, just so that you can see the difference. And I'm going to go ahead and I'm going to go to the key to the right of the 9. And do you see these down here? Do you see how there's several different that I'm clicking on? The first one with the comma says that I can have 2 functions, and then that comma means I have a domain restriction. Okay? This one right here says that I can have 3 functions with domain restrictions. This one right here says that I can have 2 functions without domain restrictions. And this one right here says I can have 3 functions without domain restrictions. So I'm going to go to this one because I'm not going to put any domain restrictions in right now. And I'm simply going to hit Control-V. Why am I hitting Control-V there? Because I still have it copied in my calculator. Do we understand that? Okay? So I just delete the part that I don't need, which is that equals f of x stuff. And I'm going to go ahead and keep that. I'm going to do it again. Get rid of the equals f1 of x. Replace the plus sign with a minus. And then if I hit enter, it gives me the entire function. Do we see that? Now, do you see this f1 underscore 1 and the f1 underscore 2? What that means is it's giving you f1 as the entire function, and it's graphing the first part of the piecewise function. And that is the top part. And then f1 underscore 2 is the bottom portion of that function. Do we all understand that, yes or no? Now, this will allow you, if you're doing your ellipses or your circles, to be able to have fewer equations in your graphing calculator. Because for all intents and purposes, I can only have 99 functions. Okay? I can only have 99 functions. Do we all understand that? Okay. Do we all understand what the hyperbola looks like? Yay or nay? Okay. So that brings me to the last one here that I want to do for example. And this one says the center is 2, -1, A is 5, and B is 3, but this time it has a transverse axis is vertical. What does that mean, y'all? I have y first, so I'm going to have y minus what? Don't give me the number, give me the letter. K, always K, do we understand that? And what is this under? It's always a squared in the first position, minus x minus h squared over b squared is equal to 1. That is the formula that I need you all to remember. Okay? And you are simply going to plug it in. This is h, this is k, so this is going to be y minus a -1 squared over 5 squared minus x minus a 2 squared over a 3 squared is equal to a 1. I'm sorry? And what would you do after this? You would solve it for y so that you would know what to plug in. Do we have any questions over hyperbolas? And what I expect out of you on tonight's homework? Okay, excellent. Yeah, you got homework over this.